So you can tell that I'm going to skip 1.1. Basically what 1.1 is pre-calculus material, and as we come across things that you may forget, please reach out and we can do that. But we're starting with 1.2, understanding the limit. For instance, we've already learned in pre-calculus how to do this portion of the graph and how to graph it. You can actually see that if we were to factor these pieces, the x plus 3 term is a term that factors x minus 3, x equals 3 is your vertical asymptote. They already tell you what the whole is, and I'm confident that you are all remembering that. The other thing that you probably remember is we wrote a lot of things in pre-calculus in this manner, where we wrote as x goes to negative infinity. It's getting closer and closer to the horizontal asymptote, which is y equals 2. Well, in calculus, we don't write it this way. We write it as limit. So LIM, I just write it in cursive, as x goes to negative infinity. So looks the same so far. We state the function, and then we write what it equals. So it's getting closer and closer to 2. So it's just a new notation for you. So as we continue on, as x goes to infinity, that is infinitely to the right. The horizontal asymptote again is 2, so the only thing that's different for you is we write it this way. Of the function is equal to 2. So as I continue on, hopefully you're understanding, is now we have this statement as x goes to negative 3 from the left. And so what we're talking about, let me just change colors for you, is we're talking about on this side of the graph, because that's the left side. In pre-calculus, we actually gave the y value of the whole, which is right here, in case you didn't know. So how we write it is with a lot less words. The limit as x approaches negative 3. Then we put this little negative sign, which universally means from the left. It's the left side of negative 3 of the function is equal to 7/6. I hope you're agreeing that this is less writing than the pre-calculus way. So what's the difference for this next one is now it's on the right side, but it's approaching the same whole, so it's still the y value of 7/6. So the only thing that's different is you're telling the reader is x approaches negative 3 from the right side. Well, the positive direction is the right side of f of x is equal to 7/6. So scrolling down, so now as we write as x approaches 3 from the left, so now we're looking at this, let me change colors again, this value. Well, the left side of x equals 3 is this. Well, it's not approaching any one value, it's just going infinitely down. So we would say that the function's going infinitely down, that's negative infinity. So limit as x approaches positive 3 from the left side of the function is equal to negative infinity. And then this one, as x approaches 3 from the right side of x equals 3, oh, I thought that would scroll up, apparently not. So same x value, but now we're looking at it's going infinitely up. So how do we write it now in calculus? The limit as x approaches 3 from the right of f of x is equal to infinity. So as they're asking the next question, it's basically getting you to write in your own words how you feel that this is represented. And I could actually just pull up the answer key, which I plan on sharing with you. Something like this. So based on what you've seen, you might want to say that the value of the limit as x approaches a of f of x represents the y value the graph of f of x approaches as x approaches a. I hope that kind of makes sense. Now this is the author's writing and how he represents it. So something along those lines. And try to use your own words, otherwise you can write what I do. So basically the value of the limit represents, in terms of the graph, it's more or less the y. I don't even like saying it is the y value. I thought that would go back. Sorry about that. It is the value that the y value approaches as x approaches whatever the a value is. Whatever value is written, say right here, 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 here. The reason why we use the phrase approaches is because x never equals -3, but we can discuss the limit that it's getting closer and closer to. So we use the phrase approaches. Yeah, so the one thing that we need to talk about the limit for it to exist, and if you paused the video earlier for the authors, in order for a limit to exist, basically what we want to say is that the limit as x approaches some a value from the left, and you have to write of the function, because if you don't write the function here, it actually doesn't make any sense, is equal to the limit as x approaches some a value from the right of f of x. And it has to equal some real number. We use a capital letter L because of the limit, where L is a real number. For instance, I like how he jumps right into this with this example, is as we write the limit as x approaches 2 from the left of f of x, that definitely is approaching, it gives a behavior, let me put it that way. So the behavior is that that function on the left side of x equals 2 is going to infinity. And on the right side, limit as x approaches 2 on the right side, it's still approaching infinity. So these behaviors are the same, but f of 2 is undefined. I'm going to use the symbol for undefined because there's no y value where x equals 2. So we can say that the limit does not exist because infinity is not a real number. Even though these values are the same, the limit does not exist because infinity is not a real number. It's more like an idea or a behavior. So you can see that the behavior of the graph goes infinitely up. But looking at this next one, well, I guess I should have wrote down no first, that this limit does not exist. And why not? Okay, so in example 2, this might seem weird, but on the left side of x equals 2, it is definitely getting closer and closer to a value, and that y value is 2. So at x equals 2, on the left side, it's getting closer and closer to 2. Slightly below it, but getting closer and closer. On the right side, that's this one. So a little bit to the right of 2. It's a little bit above, but it's getting closer and closer to 2. Now, what is f of 2? F of 2 is equal to -3. And this seems weird, but you got to trust me on this one. Does the limit exist? Yes, it does. Now, because if you go back to my definition, all it said is in order for the limit to exist, the limit from the left side has to equal the limit from the right side, and it's a real number. So let me circle what I'm talking about. The left side equals 2, the right side equals 2, so we could, since they're the same thing, we could say yes. We can actually say the limit as x approaches 2 of this function is equal to 2. Now notice, let me just go to red for a second. It does not have to equal f of 2, because f of 2 was this closed dot was -3. So as far as our limit definition, we're good so far. And then looking at the next one, just switching colors, is limit as x approaches 2 from the left side, so we're on the left side of this function. You can see like slightly to the left, we're over here, it's getting closer and closer to 3. And on the right side now, so now we're looking at this side of the graph, it's getting closer and closer to -3, this value. Even though it's an open circle, that's okay. because limits, we don't care about open or closed. Now, as far as f of 2 goes, we are looking at the closed dot. So f of 2 is equal to 3. But now, as we state what the correct answer is, does the limit on the left side equal the limit on the right side? That answer is no, so the limit does not exist. And a quick explanation would be saying the limit as x approaches 2 from the left side of this function does not equal the limit as x approaches 2 from the right side of this function. So I'm going to stop here and finish the notes in a new video.